So we didn't make any more PowerPoint slides, mainly so Hakan and I don't have nightmares about PowerPoints anymore. But I'll give you a verbal summary of what I thought was really productive and interactive and large group discussion around Team B. So we started by just reviewing the goals and the vision of the team, and then reminding ourselves of the RFI proposals. And just to kind of reiterate what was said earlier, we were tasked with coming up with what we thought might be some of the themes that came from those initial RFIs that we could take as exemplar projects to heroes or other funders to say, look, this is our vision, this is what we think could be done, this is what we think is tangible. But of course, nobody wants to put in all the effort that we've just heard from Team A and Team C to do 4 or 5 pilot projects, right? This should be a 5, 10, 20-year endeavor to which people in this room who have cohorts to bring can bring their own questions. And we've heard about some of the enabling technologies and the policy challenges to get around that, but we should see this as a vehicle for all of us to answer the questions we're all really interested in and go well beyond the 20 or so initial proposals that we had. So we started by, in some way, initially dividing the proposals that have been the RFIs that have been put forward into a couple of different bins. One that could be done largely with existing data, so without requiring new data generation, and there might be different levels of complexity and harmonization of that, and one that focused more around new data generation and enhancements. We had a very useful discussion around the additional data generation, particularly as we've heard already with respect to the idea that maybe this wouldn't be something one would just take to heroes, but actually industry engagement would be important. So, for example, we heard from Alan Schuldiner at Regeneron about their continued interest in sequencing and GWASing populations around the world, and that maybe that would be one route that we should discuss. We talked also about the idea that maybe sequencing companies, Illumina, BGI, etc., may be interested in helping to support efforts to fill in the gaps, the global ethnicity and geography gaps that we have in sequencing. And similarly, for some of the other omics enhancements that were mentioned, things like proteomics, metabolomics, etc., companies have already shown willingness to support or co-support assays in individual cohorts, and that actually if we could demonstrate to them the vision that we have here, the collective power, if you like, the collective added value of these cohorts, that these are discussions that we should have with with industry about co-funding these. So in some ways we kind of part that as longer term goals where we need to have probably reach out. We heard from other pharma companies that we shouldn't be turning up to them with a vision, but we should with the solution. But instead, we need to have more stakeholder type meetings. We need to get people around the table to hear what is it that that industry would be particularly interested in funding. And ideas that we heard, for example, were, well, if we could demonstrate that actually we could do the hard work, the harmonization of the phenotypes, particularly clinical phenotypes, and show that we had a consortium, show that we had a product to which industry might be interested in enhancing or asking new questions, then that would be great value. And there may be interest there actually in industry supporting some of the initial harmonization work to produce that product on top of which we could layer additional data and fill in gaps, particularly with low and middle income countries or understudied areas of the world. In terms of the things that we thought one could do with initial data, we had a big list of almost, I guess, a dozen or so different RFIs, and Hakan had shown some of the themes that came out of these already, things like polygenic risk scores, loss of function knockouts, uncommon diseases, etc. And we took some time to remind ourselves what the IHCC is and what its unique selling point might be. Why should we go to funders and say, this is the place to do this? We have a big collection of very large cohorts, as we've just discussed. They're not ascertained on particular disease basis. They're longitudinal, so then it's not case control studies, and that gives us opportunities in terms of looking very wide-angled at different diseases. We talked about the idea of kind of FEWAS type approaches. And so we thought about what kind of criteria should we use in terms of prioritizing what pilot or feasibility or demonstrator projects, if you want to call them that, we should take forward to funders. And we thought about things that would prioritize projects that had very wide inclusivity of cohorts. And that was one of the things that cohorts PIs were really telling us. We need projects that aren't just or not only projects that will just enable a few cohorts that have particular types of data. We need to think about ideas that will allow a wide range of cohorts to participate. So some examples of projects with very low kind of entry requirements, so perhaps some that don't require genomic or molecular data, for example. We also talked about prioritizing projects that perhaps best demonstrated this unique selling point of the IHCC. So the global diversity, for example, even some of the, as we've heard, we've just had a discussion about how much this has become a genomics consortium, but how we can also think about some of the more fundamental epidemiological questions and demonstrating those across different areas of the world. There may be some very low-hanging fruit in terms of phenotypes that can be easily harmonized. So, for example, things for which we have an ICD code that one can easily pull, and we've heard already that that won't necessarily reach all parts of the world where that would be available. But then one could think about projects that would go a step further, that would say, well, how do we start thinking about showing that this is a coherent consortium that can aggregate other types of information, other types of exposure information, or perhaps more complex diseases or phenotypes that aren't just ICD code-based. We had some discussion then about what should be the formal structure of how do we decide which projects to take forward, etc. And we've heard at the start of this session actually some new ideas about how what this consortium might do next. What we concluded at the end of the Team B session was that what we might do after this meeting is almost come up with a summary document, which would almost be like a pitch, if you like. So here is what the IHCC could be. Here is its unique selling points. Here is the type of data it has. And then here are 4 or 5 of the key themes that we think would exemplify the types of things one could do in IHCC that we could take forward to HEROES as potential feasibility pilot kind of projects to establish that we can work together, that we have a tangible product, and that with all the enhancements that we've heard about from Team A and Team C, that in the next kind of 3 years, we can then turn this into a real resource to which we can then add dozens of additional scientific projects, maybe some of the other RFIs, or maybe lots of the new ideas that people who've spent the last 2 days hearing about the IHCC would bring to the table. I think that covers most of it. Hakan, do you want to add on top?
No, I mean, I think this was very well said, Adam, and sort of the key with these themes is that within each theme there are actually several projects, and we are not necessarily ranking any of them, not all of them were presented. So they will all be sort of, you know, available, and the goal of any funding that would come in is to bring as many of the cohorts that we have here in the room together so we can amplify and sort of show the global impact of this gap filling for sort of where we have missing information, particularly on diversity. So I think that sort of is the key goal.
Right, and I think we also saw these kind of initial pilot projects as opportunities to understand where there are gaps. You know, why didn't we get as many cohorts as we thought we would into this project? Where there are other challenges, hurdles, be it policy or data, results sharing challenges, but also where there are gaps in the information in the cohorts to help inform the strategy. As we heard earlier, if we're thinking about some kind of overarching genomic strategy, this will help us understand, you know, where do we need to go bigger, and trying to design some of these kind of pilot themes around making sure that those are good outputs as well as the science that we hope to do is to inform the other parts of the consortium as well.
Maybe just emphasize again that there will be a document. We didn't want to put something up too preliminary, but we will put together a document, circulate to everybody for your input. And we would appreciate everybody's input on it, as well as needs for the individual cohorts in terms of where you stand and what you would need to participate and be involved with those themes. Those would sort of be the key points we would need to collect.
Jeff, you sat through most of the Team B session as well. Did you want to add to the discussion?
You had a great summary, thank you. And I just wanted to talk again about the industry participation and how valuable that is. And I think it looks like we've lost some of our industry representatives due to the later hour. But just one point to make is that we invited industry groups that were actively participating in cohorts right now to be part of this. And I think the future is to open the doors to a diversity of industry collaborators, and I really think it should be a collaboration, not a service provision, where the consortium can really address potentially some needs of the industry. With their contributions, we can accelerate the advancement of the science of the cohorts. So I think that point was made, I think, in the group, by some of the people in the room, but I wanted to emphasize that going forward, we anticipate having a much more active industry component.
Right, right. Gary, did you want to add anything? No? Okay, thanks.
Great. So then some more general comments about the science strategy. We've heard several ideas, some of which were presented yesterday. Not all of them could be. They're all available in your booklet. But again, these were just initial ideas, very brief, as to what might be done. It seemed, though, that there were a couple of themes that you guys identified in your meeting that might be worth sort of sharing with the group in terms of I think rare and orphan diseases was one that people felt, gee, that's an area that we can move forward. And then there were a couple of others. Do you want to mention what those?
Yeah, well, I think some of the emerging themes were, as you say, kind of uncommon or rarer conditions that therefore require very large cohorts. And again, the fact that we have these cohorts that aren't selected on a particular disease means that we perhaps should showcase the wealth of, or the breadth of different diseases one could look at. So not focus on any one specific disease area, but have multiple examples. We thought about examples like looking at polygenic risk scores across different ethnicities, again, mainly because it would showcase the breadth of IHCC, had a relatively low bar in terms of only requiring genetic data, and then again, perhaps thinking about some key outcomes that would be easily harmonizable or well recorded across all of these outcomes. There were a couple of RFIs that touched on thinking about the ideas around loss of function variants and human knockouts and the things that industry has been interested in, again, particularly focusing on the fact that some of these things are very rare. We might only have one or two in each cohort, but actually by amalgamating across cohorts or perhaps, again, capitalizing on the different ethnic groups where you may find that we have a cohort that has a much higher frequency of a variant, or for some reason is more likely to have homozygous carriers, for example. So those were some of the sort of key themes. Again, it became I think we're keen to make sure we have some non-genomic angles as well to encourage the broader participation of all the cohorts, which may be at varying stages of having genetic data. But those are some of the ones that perhaps initially seemed they could go across a lot of cohorts. They could demonstrate the use of the particular consortium that we have here. But Hakan, do you want to add some more?
And sort of emphasize phenotype harmonizations sort of across. I mean, that was a theme that the industry partners, at least, were very keen on.
So maybe we could challenge some of the non-genetic epidemiologists in the room, or the less genetic epidemiologists in the room. These are three fairly genetic-y kinds of ideas. What would be scientific areas that could be addressed across cohorts that would not require genetic data, but that would be compelling scientific questions that only IHCC could address? Yes.
So I was an epidemiologist. Two suggestions. One is multimorbidity. Though obviously genetic data would be incredibly useful for that as well. You could do a higher level analysis of common risk factors for multimorbidity and particular disease clusters which are common across different populations.
Could you maybe explain a little bit what you mean by multimorbidity?
Multiple chronic conditions co-occurring in the same individual. Co-occurring in the same individual, yes. And not just diseases, not just in elderly, but comorbidity across the life course. And we know very, very little about what the common biological causes of different disorders and how they occur differently or the same in different populations. And the second one is around common, really coming on from the million deaths presentation that we heard, common exposures and common disorders. And are there common risk factors across populations, and can we get much more sensitivity around the actual patterns between exposure and outcome with much greater amounts of data, basically.
Yes.
No, I am also not an epidemiologist, but I was thinking exactly the same in terms of environmental exposures. So that was also in the same presentation, I think, from Prabhat. what was presented with respect to PM 2.5, and in India with respect to both the individual as well as multi-morbid phenotypes. So there's an opportunity there for looking at a global environmental impact.
Well, I think I can only second what was just said, but from our angle, there is also great interest in studying more broadly and more deeply the notion of exposome. And here, obviously, cohorts have a unique value with their longitudinal dimension to study the exposure of individuals across a lifetime. And when this is in addition related to the genomic sequencing, I think it can bring additional value that we may think of. And finally, I think we are all also facing the climate change, the pollution, environment, the change in environment. And I think this is a key area that globally could be of interest to look at. And there were some hints on that yesterday during the presentations. I think, again, it's something that is quite useful, very important from the public health point of view, and does not necessarily require deep sequencing and genomic sequencing. So,
great, thank you. Next to you, so the gentleman, I'm sorry, you had a comment as well, sir, or no? It was the same. Oh, okay, great. All right, thank you.
Yesterday we saw an example with the BMI. I mean, one thing is the timing of exposures. Now we know that many exposures are important, but we don't know when they are more important. So we have tried to do some analysis, and you need large data sets to be able to stratify by ages.
Great. Other thoughts? No. Yes.
I have another one. Around the early prediction of disease. So we've got healthy populations followed over time. We can get the early indications that people are developing disease from large amounts of data.
Yes, please.
Yeah, and what about access to healthcare systems? I mean, we are cohorts from in this room are from very different healthcare systems, and it could be very, if the court has data on that, that could be very interesting to compare, to have comparative studies and so on. And I was also thinking about social determinants of health. Here also we could take advantage of the diversity of the countries which are represented through the cohorts which are in this room.
Mm-hmm. Excellent point. Håkon, and then Jeff.
Yeah, just to emphasize that, I mean, certainly many of these epidemiological measures are extremely contributory valuable, but they also become even more valuable in the context of genetic genomic data. So,
Couldn't resist, right? Jeff?
I was just going to...
yes, good point.
I was going to add that we talk about cohort enhancements and over the last couple of days in the omics realm, but I think a cohort enhancement for this discussion would be adding environmental exposure data where it's possible to do so. As the FinGen group showed us, there's a lot of value in what governments are already collecting on populations that could be added to cohorts to enhance the epidemiologic contributions. That would be great.
I have one more addition as an epidemiologist who is not a genetic epidemiologist, that I did propose something non-genetic, although I recognize that proteomics and metabolomics is rather expensive. But I think one thing that we ought to think about in terms of thinking about environmental exposures is fitting into the existing data and the data harmonization. Can we select a project that addresses a few exposure variables that can be a demonstration for harmonization that doesn't involve genetics?
Yeah, that's a good point. Nancy, did you?
So one of the things that has come up, I know at both Wellcome Trust and NHGRI discussions, are ways to impute exposures into data that lack them and can never get them. And the opportunity, I think, in this particular group where you have many cohorts with a wide variety of exposures measured, where genetics data are coming in, and other data that have genetics. Some exposure measurements may be obtained, but many will never be able to be obtained. There's a whole lot of opportunity to learn to impute exposures with genetic data in data sets where it's been measured, and then take that into some of the data sets where you can never measure it. And I think everything that is, not genetic, we make a lot of measurements. We make lipid measurements, we make BMI measurements. The non-genetic part of those measures, some of it is error measurement, some of it is stochastic, but some of it is the non-genetic part of the exposures that we so want to measure. I think there are some terrific opportunities in this particular set of data sets to really push that idea. And as genetic data come into some of the epidemiological cohorts where lots of exposures have been measured, to use the whole of your data to see that white space, to see the non-genetic part of all of the non-genetic part of fatty liver disease, the non-genetic part of BMI. Those are measures of exposures we may not be able to completely decouple, but it would be hugely valuable to be able to bring those into data sets that can never make the exposure measurements. And it's a perfect way for the epidemiology and the more genetically oriented data sets to be very useful to each other.
Well, and it's often said that geneticists put all of the environment in the error term, and epidemiologists put all of the genetics in the error term. And if there were some way to capture that error term, I think that's what you're saying, and that would be a really neat demonstration project to show how we could do that and impute it in another group.
And similarly, Mendelian randomization. I mean, this cohort is obviously uniquely qualified for a major sort of Mendelian randomization program where you can take an allele that you have validated in a certain trait, and then just you don't need the exposure. You can just use the allele across millions of people.
If you have measured the allele.
If you have,
yeah.
Right.
Great. Other thoughts about the science strategy? So I think where we were going at the end of the breakout group meeting was where Adam ended, which was basically we would like to put together some kind of a set of ideas to bring forward to the Heroes group. And we need to do that within the next couple of weeks or so. What we'd like to do is then share that with all of you and ask on a fairly short turnaround your feedback on it. Do you agree that this is a reasonable thing to propose? Have we couched it appropriately in terms of, these are not the cast in stone, hard and fast things we're proposing to do. These are just ideas, and there are many others. Those kinds of things would be very helpful to get your feedback on, if we can agree to do that. Okay, great. Anything else for this science team? If not, thank you, Adam and